और वो तो तुझे गूगल पे भी मिल जाएगा ना। हम स्टार्ट कर रहे हैं अब एसिड्स एंड एसिडिटी। देखो फटाफट से बात कर लेते हैं कि ऑर्गेनिक में जिस तरह के एसिड की हम बात करने वाले हैं, या तो वो होंगे लुईस एसिड, या फिर वो होंगे आपके ब्रोंस्टेड एसिड। ब्रोंस्टेड एसिड डोनेट्स H प्लस, और लुईस एसिड एक्सेप्ट लोन पेयर। बेटा पहले एग्जाम निकाल लिए, बाद में बनियो। चलो, लुईस एसिड एक्सेप्ट लोन पेयर, ठीक है, ये चीज क्लियर हो गई। एक फंडामेंटल याद रखो पीकेए का। पीकेए जो होता है वो इनवर्सली प्रोपोर्शनल होता है एसिडिटी के। हाई पीके वैल्यू मींस लोअर एसिडिटी, ठीक है। दो बातें क्लियर हो गई ना। अब चलते हैं। देखो सीधी सी बात यह है कि मैंने तुम्हें ये बताया था कि एक नॉर्मल एसिड जो होता है वो एच की फॉर्म में होता है, जहां पर ए जो है वो क्या है, ऑर्गेनिक पार्ट है। अब वो एनायन बनाएगा, ऑब्वियसली बात है, जब H प्लस निकलेगा। H क्या है, ये क्या है, प्रोटॉन। तो जब Ha प्रोटॉन डोनेट करेगा तो क्या बच जाएगा, ए माइनस बचेगा ना। अब बात यह आती है कि स्टेबिलिटी ऑफ ए माइनस इज डायरेक्टली प्रोपोर्शनल पीके का मतलब होता है देखो पी जो है वो पावर से वैसे डिनोट किया जाता है, जैसे पीएच में पावर ऑफ हाइड्रोजन आयन कंसेंट्रेशन बोलते हैं ना इसको, तो पी के ए का मतलब होता है, पी के एच का मतलब होता है कि पावर ऑफ माइनस ऑफ लॉग ऑफ हाइड्रोजन आयन कंसेंट्रेशन। तो ये हुआ एक तरह से, मतलब कि जो पी के ए होता है, मैं बता देता हूँ, पी के ए जो होता है उसका फॉर्मूला होता है माइनस का लॉग, ये तो पढ़ लिया होगा इक्विलिब्रियम में, के ए, ठीक है। और जो के ए होता है वो डायरेक्टली प्रोपोर्शनल होता है एसिडिटी के। तो के ए दिया हो तो समझ लेना जितना ज्यादा के ए उतनी ज्यादा एसिडिटी, और पीके दिया हो तो जितना ज्यादा पीके उतनी कम एसिडिटी। जिंदियासा जेटीडी के बारे में बेटा मैं बाद में बात कर लूंगा, क्योंकि बिल्कुल ही अलग टॉपिक चला जाएगा, आई एम सो सॉरी। मैं आपको टेलीग्राम पे इसका रिप्लाई कर दूंगा, या फिर मैं अभी क्लास के बाद आपको बता दूंगा, जब 11 बजे वाली क्लास का एंड चल रहा होगा, अच्छे से समझा दूंगा जेटीडी के बारे में थोड़ा बहुत, क्या है क्या नहीं है, ठीक है। और अभी बिल्कुल भटक जाएगा, समझाना, समझो ना, कुछ तो समझो ना, ठीक है। तो ए माइनस स्टेबिलिटी ऑफ ए माइनस इज डायरेक्टली प्रोपोर्शनल टू द एसिडिटी, हाँ बेटा, ऑफ एच ए। भाई ध्यान से समझ लो जो मैं लिखवा रहा हूँ, कि ए माइनस की जो स्टेबिलिटी होगी वो ये डायरेक्टली बात गवर्न करेगी कि एच ए कितना एसिडिक है। तो अगर याद रखो, अगर मैं तुमसे क्वेश्चन पूछूं कि HCl, HBr, HI और HF में स्ट्रॉन्गेस्ट एसिड कौन है, तो तुम्हें क्या चेक करना है, चेक स्टेबिलिटी ऑफ एनायन फॉर्म आफ्टर रिमूवल ऑफ H प्लस। तो यानी कि आपको स्टेबिलिटी किसकी चेक करनी है, और स्टेबिलिटी ऑर्डर आपको चेक करना है, स्टेबिलिटी ऑर्डर आपको चेक करना है Cl माइनस, Br माइनस, I माइनस और F माइनस का। जो इनका स्टेबिलिटी ऑर्डर होगा वही इनके कॉरस्पॉन्डिंग एसिड्स का एसिडिटी ऑर्डर होगा, ठीक है। और ये चीज मैंने पहले ही बता दी थी कि एनायन जब डाउन द ग्रुप कंपेयर किए जाते हैं तो बड़े एनायन का जो होता है वो स्टेबल होता है, तो I माइनस सबसे ज्यादा स्टेबल है, यानी कि HI इज मोस्ट एसिडिक, बिकॉज I माइनस मोस्ट स्टेबल एनायन। अब तुम कनेक्ट कर पा रहे हो ना, मैंने कल तुम्हें क्या बताया था, शुरू से देखो, मैंने तुम्हें कहा था कि एनायन जो होता है, एनायन जो होता है, कोई भी इफेक्ट लग रहा हो चाहे उस पर, एनायन की स्टेबिलिटी देखने के लिए पहले प्राइमरी फैक्टर देखोगे, फिर सेकेंडरी फैक्टर देखोगे। प्राइमरी फैक्टर देखोगे तो उसमें पहले देखोगे पॉलिंग स्केल, फिर देखोगे हाइब्रिडाइजेशन। पॉलिंग कब तक देखोगे, जब तक एलिमेंट अलग अलग है, एलिमेंट जहां सेम हुए, एलिमेंट, और इसमें भी पॉलिंग या साइज फैक्टर, इन दोनों में तब देखते हैं जब साइज एलिमेंट अलग अलग हो। अब अगर डाउन द ग्रुप है तो साइज देखोगे, बड़ा साइज, बड़ा एनायन, स्टेबल। और अगर पॉलिंग स्केल देखोगे तो लेफ्ट टू राइट देखोगे, जब लेफ्ट टू राइट सेम पीरियड के होंगे तो ज्यादा जितना इलेक्ट्रोनेगेटिव आइटम उतना ज्यादा हाई इलेक्ट्रोनेगेटिविटी उतना स्टेबल एनायन, यानी कि एसिडिटी से रिलेट करते जाना अब इसको, ठीक है। और अगर प्राइमरी फैक्टर बराबर है, मान लो एलिमेंट सेम है सारे, सपोज कार्बन है, तब तुम देखोगे हाइब्रिडाइजेशन, अगर हाइब्रिडाइजेशन भी बराबर है तो फिर तुम देखोगे पॉजिटिव चार्ज, तो जितना ज्यादा एनायन स्टेबल होगा उतनी ज्यादा उसकी एसिडिटी कॉरस्पॉन्डिंग एसिड की हो जाएगी। और फिर आओगे तो सेकेंडरी फैक्टर पे, जिसका मैंने तुम्हें ऑर्डर कल लिखवा दिया है। ठीक है, तो ये सारी चीजें एनायन की स्टेबिलिटी हम जान चुके हैं। अब बस हमें ये देखना है कि जो एनायन ज्यादा स्टेबल है उसका कॉरस्पॉन्डिंग जो एसिड पार्ट था वो उतना ज्यादा स्टेबल होगा। यस बेटा, Pauling scale doesn't means electronegativity. Actually, Pauling scale is a measure of one of the measure through which you can determine electronegativity. There are other scales also, Rosho-Muller scale और भी है, पता नहीं कौन कौन से, but Pauling is considered as standard scale. अब देखो, जैसे क्वेश्चन मैंने तुमसे पूछा CH4 NH3 H2O HF मोस्ट एसिडिक, तो मोस्ट एसिडिक कौन होगा? जिसका कॉन्जुगेट एनायन मोस्ट स्टेबल होगा। और वो किसका होगा? जिसकी हाईएस्ट इलेक्ट्रोनेगेटिविटी होगी, क्योंकि ये क्या है, सेम पीरियड के एलिमेंट्स हैं। तो आपको पता है F माइनस मोस्ट स्टेबल, तो मोस्ट एसिडिक कौन हो गया? HF। तो ऑर्डर ऑफ एसिडिटी क्या हो गया? HF H2O NH3 CH4। समझे? और ऑर्डर ऑफ बेसिसिटी पूछता तो उल्टा हो जाता। क्लियर? दिस इज हाउ थिंग्स वर्क्स। अब बात आती है, देखो मैं कुछ स्टैंडर्ड चीजों के कुछ स्टैंडर्ड जो आपके कंपाउंड्स हैं उनके मैं पीके लिखवा रहा हूँ। ये रट लेना पीके, ठीक है? ये पीके रट लोगे ना तो जिंदगी में काम आ जाएंगे। देखो ध्यान से, सबसे पहले तो मैं तुम्हें लिखवा देता हूँ मीथेन का पीके। मैं एक यहाँ पर लिख रहा हूँ कंपाउंड, यहाँ लिख रहा हूँ पीके, यहाँ पर फिर लिखूंगा कंपाउंड, यहाँ पर लिखूंगा पीके। ठीक है, अब तुम देखना कंपैरिजन मिलेगा तुम्हें कि इस क्लास के कंपाउंड्स में कौन ज्यादा एसिडिक होता है, कौन लेस एसिडिक होता है। तो देखो कंपाउंड, जैसे मैं बात करूं एल्कीन, नॉर्मल एल्कीन की बात कर रहा हूँ, नॉर्मल एल्कीन। अब ये आर ग्रुप पे डिपेंड करेगा थोड़ा बहुत इलेक्ट्रोनेगेटिविटी, क्योंकि आपके सेकेंडरी फैक्टर लगने शुरू हो जाएंगे। लेकिन अगर नॉर्मल मीथेन, नॉर्मल एल्कीन की बात करूं तो जो रेंज है वो 44 के आसपास होती है, यानी कि बहुत ही वीकली एसिडिक होता है। ठीक है, उसके बाद अगर मैं बात करूं CH4 की, उसका इससे भी ज्यादा होता है। मतलब अब देखो यहाँ पर बात आ गई ना, देखो ध्यान से समझना इस चीज को। पहले एल्कीन नहीं लेते, पहले यहाँ पर मैं लेता हूँ एल्केन। एल्केन जो होते हैं ना, उनका ऑर्डर जो होता है पीके का वो लगभग होता है 48 के आसपास। फिर मैंने कहा था अगर हाइब्रिडाइजेशन बढ़ेगा तो एस कैरेक्टर बढ़ेगा, इलेक्ट्रोनेगेटिविटी बढ़ेगी, कॉन्जुगेट आयन स्टेबल होगा तो एसिडिटी भी बढ़ेगी। तो अगर मैं एल्कीन की बात करूँ तो एल्कीन का जो पीके होता है 44 के आसपास होता है। ये सब अप्रॉक्स वैल्यू है तुम्हें आइडिया देने के लिए। उसके बाद NH3, मैंने तुम्हें कहा था कि यहाँ पर सेकेंडरी फैक्टर प्राइमरी फैक्टर लगेगा। एल्केन और एल्कीन में जो एनायन बनेगा वो कार्बन पे बनेगा, उससे ज्यादा स्टेबल नाइट्रोजन का एनायन होगा कि नहीं होगा, क्योंकि ये मोर इलेक्ट्रोनेगेटिव है तो इसका पीके और नीचे जाता है 38 के आसपास। उसके बाद आता है आपका, यहाँ पर आता है आपका क्या, ट्रिपल बॉन्डेड। अब देखो कुछ चीजें होती है, जैसे यहाँ पर ये आ गया हाइब्रिडाइजेशन। अब यहाँ पर देखो हाइब्रिडाइजेशन भी एक तरह से है तो प्राइमरी फैक्टर ही ना। तो ये वाला जो प्राइमरी फैक्टर है ये इलेक्ट्रोनेगेटिविटी वाले फैक्टर को, जो मतलब पॉलिंग स्केल वाले फैक्टर को बीट कर देता है, ये हाइब्रिडाइजेशन वाला फैक्टर। तो वैसे तो यहाँ पर C माइनस बनेगा, लेकिन इस C माइनस की स्टेबिलिटी NH2 माइनस से ज्यादा हो जाएगी, क्योंकि हाइब्रिडाइजेशन का फैक्टर ओवर पावर कर जाता है। तो याद रखना जो एल्काइन होता है वो अमोनिया से ज्यादा स्टेबल रहता है। मतलब एल्काइन का जो एल्काइन का एनायन होता है, तो इसका जो पीके आता है वो 25 के आसपास आता है। तो एक चीज याद रखना कि अगर मान लो कौन ज्यादा एसिडिक हुआ, फिर मुझे बताओ। यहां से एक क्वेश्चन बन गया तुम्हारा कि आउट ऑफ CH ट्रिपल बॉन्ड CH, कहाँ 5 मोल लगा दी मैंने? अरे यार वो, अरे यार समझ जाया करो यार, भावनाओं पे यार तुम क्या है यार। ये ले, ठीक है। तो आउट ऑफ CH ट्रिपल बॉन्ड CH एंड NH3 विच इज मोर एसिडिक, तो यहां पर प्राइमरी फैक्टर में हाइब्रिडाइजेशन वाला डोमिनेट करेगा, हाइब्रिडाइजेशन डोमिनेट्स। तो इसीलिए याद रखना CH ट्रिपल बॉन्ड CH इज मोर एसिडिक एज कंपेयर टू NH3 पॉजिटिव। और इसका वो उल्टा इस तरह से भी पूछ सकता है, आउट ऑफ CH ट्रिपल बॉन्ड C माइनस एंड NH2 माइनस विच इज मोर स्टेबल। मोर स्टेबल में भी कौन आ जाएगा, CH ट्रिपल बॉन्ड C माइनस इज मोर स्टेबल देन NH2 माइनस। ठीक है, तो इस तरह होता है। अब देखो उसके बाद आता है आपका, अब यहाँ से इंपॉर्टेंट क्लास शुरू हो जाती है। सबसे पहले अब सीधे एकदम से हम नीचे जाएंगे, ध्यान रखना। जैसे हम आ जाते हैं यहाँ पर वाटर पे, देखो वाटर का जो पीके होता है ना, वो याद रख लेना 16 के आसपास होता है। ठीक है, वाटर का। अब अगर बात करें हम एल यानी कि ऑल एल्कोहल्स, कौन से अल्कोहल्स, जितने भी अल्कोहल या फिनॉल होते हैं, अल्कोहल या फिनॉल, उनका पीके 16 से ज्यादा होता है, यानी कि वाटर के कंपैरिजन में लेस एसिड होते हैं। ठीक है, तो इनका पीके होता है आपका लगभग फिनॉल हटाओ, फिनॉल तो ज्यादा एसिडिक होता है, ऑब्वियसली उसमें रेजोनेंस से स्टेबलाइजेशन होगा ना। तो अल्कोहल जो होते हैं, यानी कि कौन से, एलिफैटिक वाले, एलिफैटिक एक्सेप्ट मिथेनॉल, मिथेनॉल को छोड़कर बाकी जितने एलिफैटिक अल्कोहल्स हैं उन सबका पीके जो है वो 16 से ज्यादा होता है, यानी कि वो लगभग रहता है आपका मैंने वाटर का पीके थोड़ा सा कम लिखा है, मतलब थोड़ा सा ज्यादा लिखा है, एक्चुअल में वाटर का पीके 16 से थोड़ा कम होता है, 15.7 के आसपास, राइट। So the pK of water is near about 15.7 and the pKs of all the alcohols, aliphatic alcohols, except methanol is almost greater than 16 or equal to. Aliphatic alcohols are less acidic than water, but phenols are more acidic than water and all aliphatic alcohols because their pK is ranges about 10, right? Now other one, अब आते हैं हम एसिड्स पे। अगर मैं if we talk about acids, then see this there is a very common acid which is known as this acetic acid, acetic acid, इसका तो याद कर ही लेना। acetic acid's pKa is near about 4.74. now see all of a sudden drastically the acidity has increased, so acid is very acidic, carboxylic acid is very acidic as compared to alcohols, right? So this thing is clear. Now acetic acid is here. Now other than that, if you have suppose formic acid, you know that formic acid is more acidic, right? Its pK is around 3.70, even more acidic. And then you need to remember one thing very clearly between this. There is a direct question that out of acetic acid and benzoic acid, which one is more acidic? So remember that benzoic acid is more acidic, its pKa is 4.22, means less pK, more acidic than acetic acid. ठीक है, see Deva, that depends that what kind of a substituents you are actually attaching. If you attach 3 nitro groups at ortho and para positions in the benzene of the phenol, then the acidity will improve drastically. So this is not the case, we can say about it directly. So we have to check the pK in that case. However, this is a general idea that I'll give you later on while we will be discussing aromatic compounds, aromatic alcohols, that whenever an electron withdrawing group is attached to a alcohol, phenol, this acidity increases, and when electron donating group is attached, it is decreased, right? So benzoic acid is 4.22, and then comes your formic acid, which is even more acidic, which is 3.770, almost somewhere around 3.70. Now this one is, now you all have heard about picric acid. Picric acid. So picric acid is nothing, the one which I was talking about, the OH and nitro. So see, I told you that in this case the acidity will be dramatically increased, right? So now this is a phenol, substituted phenol. Now its acidity is, you can say, very highly acidic. 0.70 pK. So you can now just imagine that how far the acidity has been increased for picric acid. It is even more acidic than HCl, not HCl. HCl to minus 7. Right. So keep it up to this point, and let me just tell you about a few inorganic acids also. HCl has a pKa of -7, which is very less as compared to organic acid. HI has a pKa of, as I told you that HI will be most acidic, its pKa is -10, and there is a very good acid which is known as hexafluoro antimonic acid. Its pKa is -30. It is known as super acid. If you Google it, that which is the strongest acid, then they will give you this hexafluoroantimonic acid. I guess this they will give you this one, or maybe some sulfur related acid also is there. But this is as far as I know, hexafluoroantimonic acid has a pK of -30, which is very yeah, SDF6, super acid. So remember this, okay? See, pKb is for base. To determine the basicity, we use pKb, right? Now let's move on. Now we will discuss the questions. Okay. So yeah, since we were actually discussing now we are moving into the secondary factor. So let's understand the factors affecting acidity. Now these are not primary factors, secondary, because primary factors effect, so you have discussed that if size or electronegativity or hybridization changes, positive charge changes, then this is a kind of a effect that acidity increases or decreases. We have done it. But now let's understand the effect of secondary factors that we have studied, all those effects. So the first one is inductive. So you know, I told you that all the plus effects stabilizes plus charge, and all the minus effects stabilizes the minus charge, and minus charge stabilization means increase in acidity. So you know that minus I will increase acidity and plus I will decrease acidity. Clear? So if I ask you, now clearly you know that here no hyperconjugation, because hyperconjugation will be a destabilizing factor at all, and for the anion, and always it is quite similar in all the three given examples. So there is no hyperconjugation to be checked for. There is only inductive effect because there is no resonance, no mesomeric, nothing, right? So one thing let me tell you about inductive effect is, in inductive effect, order of power is governed by a rule known as DNP rule. First of all, you will give the effect of distance, then effect of number of such groups which are doing minus I or plus I, and then you will give power, right? Now suppose we know that NO2 and NR3 plus, out of NR3 plus and NO2, which one is basically more having more minus I power. So it can be understood by the fact that I guess NO2 is having more minus I. Let me check this, because there are few exceptions are there. Let me clarify this. I'll write the order also. Uh, yeah. Oh no. NR3 plus is having high effect. Remember this. एक मैं यहाँ पे order लिख रहा हूँ. minus I का order, the order of minus I. Yes, Soumya, NR3 plus is more. NR3 plus, then SR2 plus, as I told you that effect of positive charge will be more. Then NH3 plus, then you have NO2, then you have SO2R, then you have cyanide, then you have, or we can just remove this SO2R because this is not pretty used. So I'm writing whatever is most commonly you will came across. CN, COOH, chlorine, chlorine, bromine, iodine, and then after iodine you will get this uh, COOR, or you can have this OAR group, and then you will get the COOR group, which is ester. Then you will get this OR, so normal. See what is the difference between OR and OAR? OAR means this is a O phenyl ring, and OR means other alkyl group attached with oxygen. Then you have aldehyde. Then you have uh, ketone, and then you have at the last there are others also, but you need not to remember that much. You just need to focus on few which I am marking: NR3 plus, NH3 plus, NO2, cyanide, fluorine, chlorine, bromine, iodine, that you know directly very well. Nothing else. भैया आपके पीछे लिखा है कुछ, मेरे पीछे कुछ लिखा है मतलब, अच्छा वो अरे सॉरी फॉर दैट यू नीड टू नाउ, जल्दी जल्दी देख लो भाई, फिर मैं दोबारा लगा दूं. हाउस NR3 has more effect, minus I effect. Minus with respect to what? NR3 has more minus I with respect to what you are asking. See now. Yeah, you can always see NF3. If there is NF3, then you can put it between SR2 and NH3, obviously. But there are, as to there are so many examples, right? So I've just given you a fair idea, right? So now, what was the question? Question is this. So you know that first, you know that NR3 has a higher effect of minus I, but I told you that first factor that you will see is inductive. If this is A, this is B, this is C. So first factor that you will see in inductive is distance factor. And distance wise, NO2 and cyanide wins the race as compared to NR3 plus, even though NR3 plus is having high power, but power is seen at the last, right? So NO2 and CN wins the race and beats B. So clearly A and C are more acidic because all of three these groups are doing minus I and minus I, so increases acidity, right? So you can put B at the last, right? And then out of cyanide and NO2, I told you that nitro has a higher effect than cyanide. So obviously now the power wins because distance and number are same, right? So then you will have A, and then at the uh, B, and then you will have this C, and then A. So A C B is the correct order. भैया इंडक्टिव पे DNP लगता है ना, डिस्टेंस नंबर पावर. यस सौम्य. असनी PW के पंकज सर जी को नहीं जानते. अरे ओके, शैल वी मूव. क्लियर हो गया. तो अब आता है एक इंपॉर्टेंट फैक्टर, रेजोनेंस. तो यू नो नाउ एक इंपॉर्टेंट आता है हाइड्रोजन बॉन्डिंग. See, my aim is to let you aware about all the exceptional cases that you might need to study before going to the exam. Hydrogen bonding. So what happens that suppose you are having this OH COOH. Obviously this is benzene. I will draw the multiple bonds later on. OH COOH. And then now it depends that we are talking about the acidity of which group. See, both are acidic and even acidic acid is more acidic, right? But we are not talking about the acidity of this acid, this group. We are talking about the acidity of OH with the effect of acidic acid group or COH group, right? Not acetic acid, with the effect of this carbonyl carboxyl acid group. So if you want to compare the acidity, this is suppose A, B, C, then what you want, you need to draw the conjugate anion. Sorry, not here. Here. And then this. अब ये ध्यान से रखो गाइस, आराम से करो, ठीक है. Now see what I am saying, that you might think that what happens when this O minus resonates, it will create a negative here, negative here, negative here, right? Right? So higher the stability of these negative charge, more will be the efficient resonance and more will be the ultimately stability of this anion, more will be the acidity of its conjugate acid, right? But now the thing is that here what will happen, you know that this is COOH, right? This is COOH. You know that this negative will go under conjugation here. Now the thing is negative is here. After conjugation, negative is here. So in C, there is no direct resonance. This COH group can stabilize these negative charge with respect to inductive effect only, minus I of this COH, which is very poor although, right? No resonance direct taking place to stabilize these negative charge, right? You are getting now what I am saying. So here, no R effect, no minus R effect to stabilize. But here and here, you will get a direct minus I effect, minus R effect. So clearly, the acidity of C will be at the last, right? Now, the thing is that if we talk about the ortho isomer, in ortho isomer, minus R is there. In para isomer also minus R is there. But if we talk about this negative charge, this COH group is somewhat closer, so we'll have higher minus I as compared to this one. So you can say that in this ortho group, there is both more minus R is okay, simple, common in both, but minus I is more in A, right? Because of the less distance of the COH group. But one more important factor which we are missing is that this O minus can hydrogen bond with this OH, which will give extra stability to this O minus. So that's why this ortho isomer has a very high acidity as compared to this para isomer. So you will get as the most acidic, then B, and then at the last you will get the C, right? Remember this. So this is how this ortho effect, not ortho effect, hydrogen bonding effects. This is not ortho effect. Ortho effect is when there is a, suppose there is a acid and here you have a bulky group. Then ortho effect takes place, and that I will tell you in a minute. And that ortho effect actually is considered when you are taking in the account the acidity of carboxylic acids, aromatic carboxylic acids, or basically benzoic acids, right? नहीं बेटा, why B at last? हाँ तो B, हाँ सॉरी B at last होगा, B वो मैंने उल्टा कर दिया. अच्छा एक चीज ध्यान रखना कि ये कब है, when I am concerning the comparing the acidity of proton of OH group, ये याद रख लेना. But if I was about to look the acidity of this OH, this one, then maybe there is a different order that I can see in a minute, right? You are getting it now what I am saying, that I am saying that we have looked for the acidity of this proton, that is why the order is like this. But in the same question, if I say, now I am asking you to compare the acidity of this A, B, C, but here the group that you are looking for the stability is the COO minus, not this O minus here. So now you have to look the effect of this OH group on this COO minus group, right? So here though already I told you that ortho effect here also takes place in the similar way. and minus I also takes place in the similar way. And what happened now? Due to this effect, B will be more acidic even in this anionic form when the proton is abstracted from this acid, carboxylic acid. So B is still more acidic due to hydrogen bonding. Hydrogen bonding is still there. Earlier it was from the proton of this to the negative charge of that alcohol group. Now it is reversed, okay? From the proton of this OH to the negative charge of this O minus. Clear? अरे ये बता दो if this is clear that while we were comparing the acidity of OH, while we were comparing the acidity of COOH, in both the cases due to ortho effect, or you can say not ortho effect, hydrogen bonding, you have B at the first. Now the thing is that if you want to stabilize this anion, you need this resonance, right? You need this resonance, but here this resonance is also there, right? The resonance of the carbonyl group with the benzene is also there, and in that case you will get positive here, and positive here. Am I right? Now you know that this OH is applying inductive effect on these positive charge, so it is destabilizing it. Now remember very carefully, this OH is applying minus I. Clear? So destabilizing this positive charge, meaning destabilizing the resonance of benzene ring with this carbonyl group. It means that stabilizing the resonance of this negative charge with this carbonyl group. Is this clear? Tell me. Is it clear? Or there is a doubt? Tell me. Batao. See what I am saying. Suppose there is a benzene ring. Hello. लगता है नेट चला गया. See. Okay. Let me just tell you. One by one, let me take the query. One student is saying that why we are not considering the plus R effect of OH. Let me tell you why. Because resonance will be from this side also. But this is not our concern. We are not looking for the stability of this OH. Right? We are looking for the stability of this COO minus. So resonance which are under consideration are this one and this one. Now I told you that if this resonance is high, if you want this resonance to be strong so that this negative will be stable, this resonance should be less na. See, this carbonyl can act as a resonating entity for either this pi bond or is this anion na. So if this resonance is strong, which is from benzene ring, then this will be B na, from which is from O minus. Is it clear what I am saying? Suppose there is this. First of all, understand this. Suppose there is a phenol group and there is a acid group. Now you know that there are two acids, one from this H and one from this H. So they can ask you about the acidity of either this one or this one, right? But if they do not mention anything, then you know that acid, this is benzoic acid, right? Benzoic acid is more acidic than phenol. Benzoic acid has a pKa of 4.7 or basically 4.2, but OH phenol has a pKa of 10. So you know that in comparison of these two, this COO will release the proton prior to this OH. So if not given, then you will compare the acidity on the basis of acid because it is more acidic. But however, if they ask you about which phenol is more acidic, then you have to see the acidity of this and you have to see the effect of this on the acidity of this. Clear hua? Is this clear? Tell me. Is this clear? हाँ, अब सुनो, पहले हम केस 1 लेते हैं. When acid is कार्बोक्सिलिक एसिड एंड इफेक्ट हम किसका देख रहे हैं, फिनॉल का। तो सपोज ये है, सपोज नहीं होता, सपोज होता है, मैं भी क्या बोल रहा हूँ। सपोज ये आपके पास यू हैव दिस COH COH COH, right? Now you have phenols. One OH is here, one OH is here, one OH is here. Now I am saying that which one is more acidic, but I have mentioned that we are looking for the stability of or the acidity of this proton, right? So what will happen after this proton will be released? You will get an anion. You will get an anion here, right? Don't go for answers right now. Please try to understand first, right? And you know that if I draw the structure carefully, it is like this. It is like this or not? Tell me. Now there are two resonances that are taking place. The stability of this anion depends on how strong this black resonance is. But side by side, this carbonyl group can also be in resonance with this one, releasing positive charge here, and then when this goes here, positive charge here, and then when it comes here, the positive here. Is it clear that there are two resonances? Now what I am saying, that stronger orange resonance equals to weaker black resonance. ये clear हुआ कि नहीं? So what we want to do, if we reduce this resonance orange one, ultimately the black resonance will increase and the stability of this O minus will increase, and ultimately the acidity of the carboxylic acid will increase. Now see, you have to see that there are positive charges after resonating with this CO minus carbonyl, right? So which positive charge is most destabilized by this OH? You have to see this here. So you know that this positive is directly stabilized by mesomeric of OH. It means that this orange resonance is very much dominating here. Means black resonance is very less. Means very less acidity for this COH, right? But here also direct, I told you direct mesomeric, because positive charge means empty orbital and this will give the lone pair and directly stabilizing by plus R. So here it is doing plus R, here it is doing plus R, but here it is doing minus I, because no direct contact with the positive charge means no plus R. But since OH is a relatively electron withdrawing group, so with this to this positive charge which is across this will abstract further electrons due to inductive effect of minus I, and minus I destabilizes the positive charge, right? Means destabilizing this orange resonance and stabilizing this black resonance. So that is why that is why what I am saying. Now let me just make it clear. That is why what happens, your B your B becomes more acidic than C. Now the thing about A is, even though this positive charge is being stabilized by this plus R effect, one more thing is there which is more pronounced, this hydrogen bonding. That is what I am telling you, the effect of hydrogen bonding. Ultimately, if there was no hydrogen bonding, the order should be somewhat like, you can say this order should be somewhat like A, C, and then B. But since there is ortho effect, so this hydrogen is actually forming a partial bond with this O minus and stabilizing it even more better. So you can say that A, due to hydrogen bonding, is exceptionally very high acidic. ये चीज clear हुई now? What I am saying? Is it clear? This question can be asked in exam. Don't get confused. Ortho has the highest acidity due to hydrogen bonding. Then you have meta because of the destabilization of the orange resonance or the in ring resonance, so that to stabilize the outer ring resonance, which is stabilizing the O minus and C at the last. Now let's move on to the next one. हाँ बस ठीक है, ये ले बेटा. अब यही तो बात है ना, देखो, the one who is not attending the classes or who will not see the lecture will not be able to understand these notes. First of all, why B is greater than C? B is greater than C because I told you na that here so this OH is not participating in any kind of hydrogen bonding, but the thing is plus due to this mesomeric effect, the resonance which this carbonyl, the orange resonance which this carbonyl is doing with the benzene ring, here you will create a positive charge now, and this OH here is stabilizing this positive charge, means this stabilizing this orange resonance now. And I told you that more orange resonance, less black resonance, and less black resonance means less negative charge stabilization of this O minus, less acidity. Understood? Jindyasa? Clear? So भैया ortho meta para is the order. Yes, yes, yes. For the acidity of benzoic acid substituted with phenol. Clear? Now see. Now the second is this. One student asked this question from me also on the Instagram. It is also application of hydrogen bonding. Okay. So this question can also be asked. This is nothing but the cis trans isomer of a very well known acid. One is known as maleic acid. This cis isomer is known as maleic acid, and this trans isomer is known as fumaric acid. Arey Dada, that is what I am saying. That we are not considering this resonance from OH plus, and even if you are considering this resonance, then this positive charge is getting stabilized. If this positive is getting stabilized, then it means that this orange resonance is getting pronounced. And we don't want this orange resonance to take place, so that this negative charge could have resonance with this C double bond 2. Teja, is it clear, or you want me to dive again? Instagram नहीं यार, Telegram यार भूल जाता है. So now which one is more acidic? This is A, this is B. See, this is the thing, that how we are supposed to complete these topics, I don't know. It's almost 40 minutes, 50 minutes, and we haven't done anything. Because I want you to understand the concept. Normal so you can do. Normal questions so you can do. You can just apply inductive resonance, mesomeric, falana dimkana. See, abhi in the next class probably we will discuss these questions which I have. These questions of the acidity, you will just wipe them out like nothing. But these questions are exceptional questions. That is why we are spending time on this. So B is more acidic. No, your answer is incorrect. Now see what happens. Very important. When you will have this, either one of the acid will give this H plus. So suppose this had given this H plus, this is like this, and here this is like this. Now you know that this O negative is stabilized by hydrogen bonding. So higher negative stability means higher acidity. So A is more stable than B because there is no hydrogen bonding at trans position. Clear? So this is a good question, that this is more acidic. Malic acid is more stronger acid than fumaric acid. Clear हो गया? चलो let's move to the next one. Now see. Now comes steric factor. And this is where you need to understand ortho effect. And remember, apply only on acidity comparison of carboxylic of benzoic acid, substituted benzoic acid, obviously. समझ गए? Ortho effect will only be applicable on substituted benzoic acids. Suppose you got a question like this. All these are benzoic acids, right, which are given. Right, and one is normal benzoic acid, the other one is CH3, this is CH3, and this is CH3, right? Or not just CH3, let's make it, suppose, let's make it, we can make it CH3, I guess, right? हाँ वो तो कोई दिक्कत नहीं है, even CH3 can apply this, CH3, right? Now what happens, ortho effect says at para of, अरे यार, at para of benzoic acid, if there is a bulky group, ortho effect takes place and increases acidity. Now what happens, see, अगर मैं तुमसे जनरल ऑर्डर पूछता, if I were to ask you about the general acidity order of this benzoic acid, then you know that negative will be here, negative will be here, negative will be here, negative will be here, and that's how you know that you will apply the same concept. That again, there are two resonance. Let's understand in the same way. One is this black resonance, one is this orange resonance. And one thing is clear, orange resonance inversely proportional to black resonance. And for high acidity, high black resonance is needed. ठीक है, अब देखो, ये O माइनस यहां से रेजोनेंस करेगा, ये बेंजीन यहां से रेजोनेंस करेगी. जब बेंजीन यहां से रेजोनेंस करेगी तो ऑर्थो पर और पैरा पर पॉजिटिव चार्ज आएगा. अब क्या होगा, अगर यहाँ पर मिथाइल ग्रुप होता, नॉर्मली की बात कर रहा हूँ, नॉर्मली when we are talking, not talking about ortho effect, we are just considering this as the CH3 group, you know that there will be hyperconjugation, right? And there will be high plus I, right? See, you are getting it now. And if CH3 were here, CH3 is here, suppose, then there is no hyperconjugation, only plus I. And here, if you see, there will be hyperconjugation and medium plus I. Now the thing is that if you look in this way, if you are looking in this way, then you know that okay, this is a you can consider it, if we talk about this plus I with the reference of this O minus here. So you know that plus I destabilizes the negative charge, so there will be a high plus I means higher destabilization of this negative charge, because hyperconjugation is both here in ortho and para. So you know that ortho and para are greaterly destabilizing this O minus, because due to hyperconjugation stabilizing the orange resonance, and due to plus I effect destabilizing the O negative. So ultimately you will say that yeah, ortho and para will have the less acidity as compared to meta, but this is when we have no ortho effect. But what happens in ortho effect, see, now the thing is when ortho effect comes into the rule, now things get changed. See, if you have this, and if you have CH3 here, now what happens, that due to this H, and H, this H repels this complete group and making this group, this particular group, quite out of the plane. What happens then, the resonance of this benzene with this group now is quite hindered due to the repulsion between this. Array, understand this. Suppose this is the plane. In order to have resonance, we know now that atoms should be in one plane. So your COO is like this. So suppose you have CH3 here. Now this is a big group, right? So what will happen? Earlier the resonance was taking place, but when as soon as you applied the methyl or bigger group at ortho position, na, this COO minus actually tilted a bit and became out and went out of the plane. Due to which, what happens? This becomes like this. This double bond comes out of the plane and this goes below the plane. Now this pi bond and this pi bond are not in the same plane, so the resonance is somewhat hindered. So as you have hindered the orange resonance, the black resonance will effectively work, meaning the more acidity of carboxylic acid group attached to the benzene ring. So now you understood that why ortho effect is actually increasing the acidity of this benzoic acid exceptionally. So if the order is A, B, C and D, you know that this you can say this B will be highly acidic. Then generally, what is this CH3 doing? This CH3 is doing what? The stabilization of this negative charge, this CH3 and this CH3 is somewhat destabilizing, right? So you can say that B, then normal benzene will be there, and then you will have C and D, and out of C and D, you know that D will be more destabilizing because of the hyperconjugation to the positive charge, making orange resonance stronger, and then C because of the no direct plus R effect. So this is the order. Is it clear or not? Why these are the questions na? If they come in the exam na, 99% of the students are failed to answer correctly. That is why I am saying that बिल्कुल ध्यान से समझना. Even if it is not clear, then you can ask me again and again. So now is it clear? Okay, very good, very good, very good. So this is how you need to see. Now if in the same thing na, if you have this COOH group here and you have this isopropyl group here at ortho metapara, or you have this tertiary butyl group here at ortho metapara, the same concept will be applicable. Even if you are having chlorine, bromine or iodine at ortho para meta, then also ortho effect will be considered, and that's how ortho will be having highest acidity. For example, if we talk about this one, yes Soumya, you are right. अरे मैंने सेम जगह लगा दिया. You have a class from 10 na? Do you guys have a class from 10? Anjali, these things are not, you know, explained in a proper way theoretically. This is somewhat more practical. We need to have a somewhat more practical approach to it, first of all. Right? And suppose there is this normal benzoic acid. Now, if I mark it by A, B, C, and D, then I told you that the thing is that there will be ortho effect here also. So, due to ortho effect, A will be greatest due to ortho effect. Right? A will be having greatest acidity. Now, comparing this, and this, what effect? What is the basic effect of Cl? Now let me tell you that the basic effect of chlorine. You have seen now that this Cl group also does this plus M effect with the benzene ring, right? So same, exactly same as it was in the case of phenol. So you know that Cl here will not having any direct effect because the resonance with this carbonyl group will impart plus charge here, here and here. So no direct plus M from the chlorine to stabilize this positive charge. So orange resonance is not that much pronounced in meta. So meta will be then the more stable, right? And then this C part, and then at the last D part. And why C part is actually here more than D? Because of the very high inductive effect of halogens. I know that there are few things that you will keep as a doubt, but please these are the few questions that you need to practice again and again, because if anyone comes from this particular section now, I'm sure that you will do the right if you have revised these questions. Please revise these questions. I'm not discussing those questions which you can do at the last, at the end moment by your general knowledge. No, these are the questions that have some exceptional cases. That is why marking this question important is very much worth to do. See, ortho effect is clear. Bulky group, chlorine, bromine, iodine, methyl, isopropyl, tertiary butyl at ortho position, and when you are dealing with the acidity of benzoic acid, ortho is having highest acidity, right? Now, you know that this meta group is not supporting the orange resonance, the in ring resonance. Thus, this O minus will have higher resonance with the carbonyl and thus more stability, more acidity. So B is more. Now, C and D. Out of C and D, generally in the case of phenol, D was more stable, and then at the last there was C, right? This was the order. Matlab D was there, phenol was there normally, and then you were having this other groups. But here the thing is that since chlorine has a very high, halogens has a very high minus I, so as compared to normal benzoic acid, if you apply Cl group here, Cl group here, Cl group here, then what will happen, that at least some minus I will reduce this negative charge, stabilize this negative charge, right? So due to that, benzene is kept at the last here. So benzene, normal benzoic acid has a pK of 4.2, so least acidic, now followed by ABC. Yes, in C plus M is also there. Array, that is what Saurav I am saying now, that this plus M is going to support this positive charge now, and in turn stabilizing this in ring resonance with carbonyl, which we don't want to get stabilized because we are governing the stability of this H. O minus. Yes beta. Shravani, yes. So अरे क्लियर हुआ कि नहीं हुआ? Is it clear? Tell me if it is clear. And do you have class from 10? Do you have class from 10? Yes, yes, yes. मैंने थोड़ा सा वो गलत मार्क कर दिया. वो तो मतलब explain, we have explained in the same way, but the thing is, yes, obviously C and then D. Okay, chalo, if there is no confirmation, then let's move forward. If any message pops up, then just tell me, I'll leave you. Chalo, okay. Now, a very known question that comes is this one. Fluorine here and chlorine here. Now this is the biggest, mythical question. In this question, students are always confused that at this position, do we have to see the higher plus power, plus M power, or we have to see the higher inductive power? Which effect to consider? Because students have been told that in halogens attached to the benzene ring, always look for the inductive effect, right? So now let me clear this type of question. And even if there is iodine also, then you can do it in the similar way. Here, the exact answer is this. Always remember that this is more acidic. Na, that is the thing, na Teja. What you are thinking, na, that suppose you have this COH, O minus, and you have chlorine, and you have fluorine. Now, what you are thinking that fluorine has, now look closely, that here you have, when you will having this resonance, now you will get positive here, then it will go here, positive here, and ultimately positive there also. Similarly, here you will have positive. Now tell me that which positive charge is more destabilized. Now the thing is that if you consider the plus M is higher in chlorine, but if you consider the inductive is higher for fluorine. And I told you that inductive is priorly more important for halogens rather than mesomeric effect. So here the dominancy of this takes place, right? Is it clear? नहीं 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 नहीं, अरे मैंने उल्टा लगा दिया क्या? सॉरी सॉरी सॉरी, उल्टा लग गया वो गलती से। वो ये वाला होगा, ऑब्वियसली यही होगा, यही होगा। वो तो यहाँ पर आपका नाउ दिस इंडक्टिव विल टेक्स प्लेस ना, माइनस आई डोमिनेट। तो माइनस आई डोमिनेट करेगा तो प्लस चार्ज को ज्यादा डिस्टेबलाइज करेगा, मोर डिस्टेबलाइज। So more destabilization of this orange resonance, which let me just do it permanently with the orange one. So orange resonance is more destabilized. So black resonance is stabilized. So more acidity in fluorine, right? So यहाँ पर A आएगा. So A is more acidic than B. Right, 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 right. More acidic. Clear? Is this question clear? Is this question clear? Tell me. But now the thing is going to change. Suppose you have this chlorine and chlorine here. Now also you are going to get positive charge here. Now what you think? So that will be the acidity order. Similarly, inductive will be dominating. So what do you think? So that fluorine will still be a more acidic, or any other thing going to happen in this particular case? So here, this is the thing that B is more acidic. Why it is so? Due to the ortho effect. Since chlorine is bigger in size, so it will have ortho effect. So you can say ortho effect of Cl more than chlorine because it is bigger in size, right? So here, so remember, these are the very good form of questions that can give you some extra marks other as compared to the other students. If chlorine, bromine, chlorine is at the para position, then fluoro wins due to the high inductive, and at ortho, chlorine wins due to high ortho. And this similar question can also come with fluorine, chlorine, bromine, and iodine. So just follow up the same rule, right? Now, at meta, there is no significant effect. I am just discussing those which have a fair probability to come up in the exam. Normal benzoic acid. Now you know that what is the nature of basic nature of OMe is plus M or minus I, right? Now the thing is, again here ortho effect will take place. Obviously OMe is also a bigger group, right? Because of the methyl part, right? So here also A will be most acidic because of the ortho effect. Now the thing is, again you will get two type of resonance in benzoic acid, the orange one, the black one, right? So one resonance is inside, this is orange one, this is the orange resonance, right? And then you have the black resonance in the benzoic acid, this COO minus. So this is your black resonance. So we want to let dominate black resonance for the stability of the conjugate anion of the carboxylic acid. So you know that here positive will be here due to the orange resonance, and this lone pair will not be able to stabilize any of these positive because of the not direct contact, because of no direct contact. So there will be no plus M, and even this minus I is going to destabilize this positive charge. So immediately you will understand that okay, due to least plus M and high minus I, we are going to get a fair idea that orange resonance is destabilized, so black resonance is dominating. So ultimately the stability of the O minus is increasing and acidity of OH is increasing, so P will be more stable as compared to C and D, right? Now the thing is that out of D and C, when there is no OMe, when there is no OMe. So generally what OMe was doing, OMe was actually providing electron density to the benzene ring, right? And there here you got negative charge, so you are destabilizing the O negative. So D, you can say is somewhat, at least you can say it will come after C. This is somewhat, you know, there are few things which cannot be explained as accurately. This is the practical data, that is why I am putting these questions. That then you will have this normal benzene ring, because it has a benzoic acid, it has a pK of 4.2, D has the pK of 4.1, and this is having the pK of 4.09, and at the last you will have the para isomer. Why para isomer is at the last? Because you are going to stabilize this positive charge directly with the mesomeric, so very high orange resonance, right? So very least stable conjugate anion O minus, and thus least acidic. So it is near about 4.47. So remember this. अरे यार ये मैंने उल्टा कर दिया, sorry. Benzene will be here now. Benzene is D and then C. हाँ राघव, नाउ क्लियर. अरे वो पता नहीं यार क्या हो रहा है आज, वो ठीक है. Para isomer is at last, right? OMe shows plus M बेटा, लोन पेयर है ना. देखो माइनस एम की खास बात बता दूं, माइनस एम इज ओनली शोन बाय दैट पार्ट विच हैज एटलीस्ट वन मल्टीपल बॉन्ड. इफ एनी ग्रुप हैज मल्टीपल बॉन्ड, इट हैज अ फेयर चांस टू शो माइनस एम. क्लियर हो गया? अब देखो जरा, सपोज ये है तुम्हारे पास, बेंजोइक एसिड के सारे केसेस करा दूंगा ताकि तुम्हें दिक्कत ना आए. However, giving a proper explanation for every trend is somewhat difficult, because things are somewhat more practically driven, na? In acidity and basicity. What is there? What is there actually? You cannot have a debate, much debate on that. So here you have bromine, suppose Br, 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 and normal phenol. So basically, what you need to understand that presence of bromine in this way, again ortho effect is there, so A will be greater, ortho effect. Then again B, due to the similar reasons that we have studied, right? Then you have C, and then you have D. Here benzene is at the last because of the high inductive power. I told you that the high inductive effect of these halogens, this O minus is very much stabilizing as compared to the fact when there is no halogen group. So D is at the last. While comparing the acidity of any chloride, bromide substituted or iodide substituted benzoic acid, normal benzene ring will be at the least acidic point. So as the OMe is not showing any effect at meta, then it shows the same effect at benzoic acid. As OMe is not showing any effect at meta, then it shows same effect as benzoic acid. No. It is showing plus I, na? Oh, sorry, minus I, na? OMe at meta is at least showing minus I, na? Because you have this OMe here, and in the benzene you have positive charge here, So at least destabilizing this positive charge na, through minus I, and thus destabilizing the orange part or internal resonance. So you cannot say that it is as equivalent as normal benzoic acid na. चलो, तो क्लियर हो गया इतनी बात? बताओ मुझे, क्या ये क्लियर हो गया है? और ये क्या? अच्छा, चलो ठीक है, फिर अगले केस पे चलते हैं। चलो, अब इसको मैं कॉपी कर लेता हूँ पहले। ओके ओके ओके, चलो अब देखो, अब आता है तुम्हारा ये मिथाइल वाला हो गया हमारा, फ्लोरीन वाला भी नॉर्मल है, फ्लोराइड वाला भी सेम पैटर्न फॉलो करेगा। दिस सेम पैटर्न इज फॉलोड फॉर F substituted, fluorine substituted, chlorine substituted, and iodine substituted benzoic acid. Similar. That is why I have just put one example. Now, another important one is this. Wait, Jindyasa, let me see this. Just write down this NO2 group, then this benzene ring. No. Yes, what you are saying. जिंदयासा बेटा आपका कमेंट कहाँ पर है मुझे समझ, हाँ डिनर बाकी है, 10 मिनट ब्रेक। अच्छा अच्छा अच्छा, ओके ओके ओके, जस्ट गिव मी 10 minutes, right? At 11:30 sharp I will give you the break. PR is an electron leaving group. I told you, Teja, that inductive effect is dominant for halogens as compared to this mesomeric effect. So bromine is first considered as electron withdrawing group, then considered as electron donating group. Right? कहाँ चला संयुक्ता? अरे बताओ इसका आंसर तो बताओ। ये 11:30 क्या कर रहे हो तुम? 11:30 क्या हुआ? मैंने बोला क्या 11:30? मैंने बोल दिया क्या 11:30? मैंने तो 10:30 बोला था ना। अरे अरे यार तुम लोग, अरे अभी छोड़ रहा हूँ 10 मिनट में। एट 10:30 आई गिव यू अ ब्रेक ऑफ 15 minutes, डू वट एवर यू वॉन्ट टू डू एंड देन कम बैक। अरे यार गलती, माफी भाई माफी, हाथ जोड़ो भाई, माफ कर दो, मारो मत मुझे। तुम ये बताओ फटाफट। नाउ सी, अच्छा देखो, लेट मी गिव यू अ फेयर आइडिया। when halogen substituent, suppose now understand this, बिल्कुल ध्यान से समझ लो, मैं बता रहा हूँ नहीं तो पेल दूंगा पकड़ के। If there is some substituent X at here or at para, some X group, either at ortho, meta or para, right? Now, how will you determine that whether normal benzoic acid is more acidic or less acidic with this X group as compared to this X group at ortho, meta or para? Now, the fair general idea is that when that group is electron withdrawing, that X group is electron withdrawing, so it will overall stabilize this O minus, right? Because it attracts the electron, so it will destabilize the, stabilize the negative charge, negative electron density. And when this X group is electron donating, then normally, as compared to the normal benzoic acid, it will destabilize because it will donate the electron density ultimately to this O minus, which is already electron dense. So that is why when there were methyl, there were isopropyl, there was tertiary butyl, there was OMe, all these groups, these were generally electron donating group. That is why the normal benzoic acid was placed at somewhat higher, keeping aside the ortho effect, right? but when there is an electron withdrawing effect of X group is more. Just like in case of halogens, even we know that halogens has a plus M effect also, but minus I is dominant. That is why normal benzoic acid was considered less acidic as compared to any halogen substituted benzoic acid. And similarly here, normal benzoic acid D will be at the last because NO2 will at least abstract some electron density, right? नाउ अभी यहाँ देखो ऑर्थो इफेक्ट तो यहाँ पर अगर नहीं भी होगा तो बहुत ही स्ट्रॉन्ग माइनस एम नाउ तो माइनस एम लग रहा है ना सो अब तो यहाँ पॉजिटिव एम प्लस को डिस्टेबलाइज कर रहा है जो प्लस चार्ज तुम्हारा यहाँ बनेगा ऑरेंज रेजोनेंस से द NO2 will destabilize it. So now the thing is that NO2 is destabilizing this positive charge at max at ortho, and due to the minus I, very high minus I, also stabilizing this direct O minus also. So ortho is still at the first position, even not due to the ortho effect, but due to the strong minus I and minus M effect of NO2 group. Is it clear? A is at the first position, then C, and then B. Any doubt? नहीं बेटा, COH और NO2 के बीच में अगर देखो H चला गया है, once proton is attracted, there is no H ना, H ही नहीं है तो हाइड्रोजन बॉन्डिंग कहाँ से होगी? क्लियर? नाउ सी, ये बहुत इंपॉर्टेंट है. No Shivam. Once this H is abstracted, there is no H left either at NO2 or COO minus. Na, so how you are going to do that? B is greater than C. No. Here to the mesomeric effect of NO2 is destabilizing the orange resonance. Na, that is why C is at the high priority ना for acidity. अरे समझ रहे हो नहीं समझ रहे? तेजा, is it clear? When this X group was electron donating through plus M, then we were saying that this B, since it has no plus M, no orange resonance stabilization, it was more acidic as compared to C inside the para substituted form. But here to NO2's para form will stabilize the black resonance by destabilizing the orange resonance na, by giving strong plus I, strong plus M ni minus M to the plus charge. Arey, I told you na that minus effect destabilizes positive charge. So what's the thing? What's the matter? D greater than B. So D will be the least. I told you that the effect of normally NO2 will be stabilizing for acidity of the benzoic acid, right? Because it is having at least some minus I. This is the problem of teaching in English now, that sometimes we are not able to clarify few things. But it's okay as long as you are understanding. Now see, benzoic acid, you know, 4.20. Now I'm writing the data. Ortho effect, that is why यहाँ ऑर्थो इफेक्ट भी है प्लस हाइड्रोजन बॉन्डिंग भी है, राइट? Because as soon as this H will be fetched na, the other H, just like in the case of fumaric acid, not fumaric, I don't know, the one isomer which was cis isomer, there will be H bonding, right? H bonding plus ortho effect. So that is why ortho, so no one is going to beat this ortho. So A most acidic, then you have B, and then you have C. So A, B, C, and D. I also told you that whenever, now C, okay, so this is the practical data, so you need to remember this orders, okay? I practice these questions few times, you will get to know about it, all right? At least please remember these things. Reason so I told you that you need to compare the black and the orange resonance, right? Now, one very important thing, remember Ohm's gap. इसको याद कर लेना भाई. And acidity order is O M S G A P. This is the order of acidity. How is C more than D? That is the thing, na. That is why I'm saying you, na, that you cannot fight. You cannot fight from any other. You can say. um uh, you cannot fight with the practical data. I was also thinking that D should be at the last because at least COH will have some minus I effect on this CO minus, but here it is not like that. So that is why I'm telling you that just look closely for those questions which are not having any proper reason. I can give you some reason that is vague, but even in the books, the good books, there is no reason for these all stuffs. It is what it is. So just remember these things, few things. However, 99% of the time I have given you the fair reason. But this one time when there is no reason, I cannot do anything. Now this is how it is. So just remember this. So yeah, the full form of Ohm's gap is oxalic acid, acidic then malonic acid, acidic then succinic acid, acidic then glutaric acid, then adipic acid. ये पढ़ा होगा. You might have studied adipic acid in polymerization, preparation of nylon 6,6, and the last is pimellic acid. Now, what are the structures of these compounds? Very easy, very easy. You know oxalic acid, na? This is oxalic acid plus one carbon in the chain. You will get malonic acid. एक CH2 ऐड करते जाओ, नेक्स्ट पे पहुंचते जाओ. प्लस वन CH2. So you will get COH, COH, CH2, CH2, COH. This is your next one. This is malonic. This is succinic. Then if you add one more, so you will get this COH, CH2. I'm writing in a short form. 1, 2, 3. COH. This is your glutamic acid, glutaric, sorry. Then 4, when there are 4 CH2 groups, it is adipic acid and pimellic. हाँ, homologous series है. And the reason for that, you know, that as soon as you get a negative here, the minus I with the increasing distance decreases, so the stability of this anion decreases. So the acidity decreases. In oxalic acid, when you have O minus here, the maximum minus I you will get because of the least distance of this COH. And since it is a minus I group, it is going to stabilize this by minus I. So the reason is minus I. As the distance of the minus I doing group, the other COH group is increasing, the acidity is decreasing. क्लियर? बताओ भाई, क्लियर हो गया? इज इट क्लियर? हाँ बेटा, होमोलोगस सीरीज ही है. बताओ भाई, इतना क्लियर हुआ क्या? ये भसड़ क्लियर हुई? नाउ वेरी इंपॉर्टेंट क्वेश्चन. And if you know the pKs now of these few compounds, then you can directly answer it. No need to go for the effects. However, I will give you the reason possible. But you know so far, it is 3.7. I told you pKa. It is 4.2. It is 4.7. So you know that acidic order is directly A, B, and C. No issue. Directly. अरे हाँ हाँ. Okay. ये clear हो गया question? This question is clear, right? Reason you know. That here you will have a resonance, here also you have a resonance, but here the thing is that यहाँ पर sp2 hybrid carbon है यहाँ पर, so that is why चलो इसको मैं इससे नहीं बता रहा, आगे बता दूंगा. ये मैंने पीके से ही सॉल्व कर दिया वैसे, पर रीजन में बता दूं. ठीक है, रीजन आगे बता दूंगा, आ जाओ पहले काम करो, कब क्लास स्टार्ट करना है ये बताओ। व्हेन यू वांट मी टू स्टार्ट रीस्टार्ट द क्लास। टेक 15 minute break, okay? It's 33. We will start the class at, it's 34. We will class the class start the class at 40:50. No, 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 not 11. It will be 25 minutes now. Let's start at 11:50. Go. 11:50 nahi. 10:50. We will start the class at tomorrow. We will start the class at 10:50. Okay, today I have to finish this acidic module. I don't know. I have to finish this Brett's rule and everything because I have seen questions related to that also. Okay, 10:50 पे आ जाना भाई. Okay, bye.